A very good day to Dr. Ruwaida and also my fellow classmates. My name is Ashley Chua, and together with Cyril John, we will be presenting the Air Pollution Control Engineering project paper on coal-fired plants. This is the table of contents in which we will be touching on in today's video. First of all, I'd like to introduce the coal-fired power station as a type of fossil fuel power station. The coal is usually pulverized and then burned in a pulverized coal-fired boiler. The furnace heat converts boiler water to steam, which is then used to spin turbines that turn generators. And coal-fired power stations generate over a third of the world's electricity, but causes hundreds of thousands of early deaths each year, mainly from air pollution. So the chemical energy stored in coal is converted successfully into three different types of energies, mainly thermal energy, mechanical energy, and electrical energy. So in this particular study, we'll be discussing the typical amount of material loading to a coal-fired plant. And for our current study, we are taking the plant capacity as 2,100 megawatts. The total coal consumption would be 833,000 kilograms per hour. Coal consumption for each unit would be 280,000 kilograms per hour. And the air pollution control devices that we are using for this study are the electrostatic precipitator and also the seawater flue gas desulfurization. So how would one calculate emission factor? You can do so by you can get emission factor from the products of pollutant concentration with flue gas divided by the coal feeding rate. In this paper, the typical air pollution control systems we'll be using are the electrostatic precipitator, ESP, and the flue gas desulfurization system, FGD. So this figure explains the FGD process installed at a thermal coal power plant. The FGD system is installed to the thermal coal plant purposely to minimize the production of sulfur dioxide present in the flue gas before it's released into the atmosphere through the stack. The FGD flue gas fan is designed to extract the correct amount of flue gas for desulfurization, while the remaining flue gas bypasses the FGD and is used to reheat the treated flue gas upstream of the stack. The FGD plant can be put online or offline without affecting the power generation process, provided sufficient control of the ID fans. From this study, the sulfur dioxide distribution in flue gas outlet increases with sulfur dioxide production in the stack. This figure shows the sulfur dioxide content in flue gas outlet at the stack with the FGD process. As expected, the most sulfur dioxide that can be treated throughout the FGD system, the more sulfur dioxide can be produced at the stack. Therefore, it is important to ensure the complete process of FGD plant in order to meet the simultaneous production of sulfur dioxide. The relationship between coal sulfur content to the sulfur dioxide production in the stack is represented in this figure. The amount of sulfur dioxide production in stack increases with the percentage of sulfur dioxide content in subbituminous coal. Therefore, the selection of subbituminous coal used for firing the furnace can be predicted with the sulfur dioxide production in the stack. So the FGD system process is about 50 to 70% efficient. And the system successfully reduces sulfur dioxide emission and complies with the Clean Air Regulation 2014 Malaysian Act. Next, I will talk about the electrostatic precipitator. It electrically charges the ash particles and imparts a strong electric field in the flue gas to collect and remove them. An ESP comprises of a series of parallel, vertical, metallic plates, forming lanes through which the flue gas passes. Centered between the collecting electrodes are discharge electrodes, which provide the particle charging and electric field. This figure shows a plan view of a typical ESP section, which indicates the process arrangement. Electrostatic precipitators are extremely effective and are capable of moving more than 99% of particulate matter. The effectiveness of a certain precipitator is determined by how well the specific device deals with the unique features and problems of the plant it is used at. Additionally, precipitator effectiveness is also determined by the temperature and moisture content of the flue gas. Next, I would like to pass the second half of the video on to my partner, Cyril. Thank you.
In this study, the gas sample being investigated are polychlorinated dibenzoyl p-dioxins, PCDD, and polychlorinated dibenzofurans, PCDFs, which are pollutants emitted as a result of coal burning process. They both have low water solubility, low vapor pressure, highly persistent, and tend to bioaccumulate. In this stack sampling, there will be 4 configurations with different coal type and air pollution control device combination in the form of ESP and FGD. The coal type being processed being subbituminous and also bituminous coal, with the subbituminous having lower calorific value, carbon and sulfur content. The flue gas desulfurization operation will be turned on off for different configurations in order to observe its effect on the pollutants removal. By using the equation mentioned earlier, the emissions factors are calculated using the data provided. As we can see the result in the following table, we can see the comparison between different configurations with the run ID number 1 has the highest emission factor without the FGD operation being turned on, and both run ID number 2 and 4 the value of emission factor 0.08 shows the least emission with the help of FGD operation. And also, as we can see, the PCDD and PCDF concentration still within the limit value of the OE requirement. Moving on to the Department of Environmental Requirement. So according to the Environmental Quality Clean Air Regulations 2014, second schedule of limit values and technical standards, the PCDD and PCDF limit value stands at 0.1 nanogram TEQ per meter cubic. Hence, the minimum efficiency for the electrostatic precipitator is at 99% in order for us to maintain the emission below 0.1 nanogram TEQ per meter cubic. And furthermore, the addition of air pollution control device in the form of flue gas desulfurization (FGD) can be implemented to further reduce the PCDD and PCDF emission. And that is all for our presentation. Thank you.